Hello, I'm Professor Andy Lowe, based here at the University of Adelaide in South Australia, and welcome to my Study Australia Masterclass. I'm a biologist by training, but really specialised in genetic resources and the understanding and dynamics of biodiversity, genomics, and ecosystems, particularly forests. Globally, food and natural resource production is going through the biggest change since the Industrial Revolution. But unlike previous changes, the changes today are a complex mix of new technologies and global drivers that are changing the food production system. And many of those are focused around sustainability issues. We're going to be taking an exciting journey of discovery, looking at how we can reintroduce bees onto farms, use DNA to track illegally logged timber in supply chains, transform food waste into useful products, and we're also going to talk about how we can harness the cellular mechanism of plants and animals to produce the foods of the future. So let's take a look at some of these key drivers that are changing the food production system. We know that there are issues around food security. The population is growing, estimated to reach 9 billion by the year 2050. We're probably producing enough food, it's just not being distributed equitably around the planet. We're also seeing incredible changes in demography. We're getting an increasing middle class right across the world, and they express their choices through food choices. And those choices are becoming more choosy. People want to eat better. They want to eat organic foods. They want to eat locally. They want to eat sustainably produced foods. And that consumer choice is having a massive influence on food production systems. At the same time, the food production systems that we rely on have driven a wave of environmental devastation across the planet. And it's not a sustainable system that can keep producing at the rate it has been in history. We're also seeing lots of changes globally. Global systems are changing. We're having economic crises, global pandemics, and these are all affecting the way that we move food and trade food around the world. And finally, the other key driver is really around technology and the role that technology can play in helping to solve some of these solutions. Technology in the context of agriculture, known as agtech, it comes in many different forms. We might have robots on the ground, lasering out weeds. We might have drones that are surveying the fields and the growth of those plants. We might use computer vision to capture that imagery. And we might have a network of sensors or the Internet of Things around farms that are capturing information and processing that information to deliver decisions up to farmers so they can best optimize their production. You know, the dream is to have a fully automated farm that the farmer can just drive from their kitchen while they're making a cup of tea and the drones are out there in the field. Well, we're probably a few years away from that at the moment, but it's coming. A lot of those technology solutions are actually driving sustainability outcomes. And when we look at where technology is being applied, we see issues that are tackled around energy consumption, a more efficient use of water, and then reduced inputs into the farm, particularly around the reduction of pesticides and herbicides that will allow farms to move towards organic production and open up new markets in particularly discerning locations. We've just had COP26 in Glasgow, and you may have your own opinions on how successful that was, but there is this increasing awareness of the importance of sustainability that's affecting thoughts and action around the globe. May not be quite occurring as fast as some people would like it to, but an important framework that's been put in place through the United Nations is the Sustainable Development Goals. These are a number of goals that are really aiming to highlight and ultimately achieve sustainability in key sectors. Food production is one of those. Zero poverty is another. Gender equity, education for all. These are all key milestones of sustainable societies. But we also need to achieve sustainability around life on Earth, life in the sea, and climate adaptation as well. And achieving sustainability is around balancing these particular outcomes and pressures, and achieving growth in these sectors without diminishing economic returns. It sounds like an impossible task, but if we demand solutions for these sustainability challenges, then investment, technology gets applied into these areas. So there's a very intricate and complex dynamic between consumer demand and then technology and sustainability solutions that are put in place for those. Let's consider the scale of environmental degradation that we've wrought upon the Earth. Sounds a bit dramatic. It is a bit dramatic. Well, the challenges that we put in place are pretty dramatic. 80% of all land clearance has been driven by the agricultural sector, clearance for production of food. Of course, we need to eat. We need that food production to sustain the 7 billion people that are currently on Earth. But we're running out of land to clear to sustainably support 8, 9, even 10 billion people. And if we continue to clear at that rate, we're going to continue to come across the problems with the environmental degradation that we've put in place. We've driven to extinction large numbers of species. Many of those species haven't even been described yet. They're called the dark taxa. It's a bit like the dark matter in the universe. We haven't put a name to those species and they've gone extinct before we even knew they existed. Many of those species will be in the Amazon, the Congo Basin in Indonesia, these large tropical rainforests that harbor more than 50% of life on land on this planet. But also we've wrought a broad range of environmental degradation in different systems. And if you were to group up all of the degraded areas on Earth and put them in one place, let's call it the Federated States of Degradia for sake of argument. So the Federated States of Degradia, how big would this nation state of degraded lands be? Well, it would be larger than Russia. And it would also house more than 3 billion of the most disadvantaged peoples on Earth. We need to reverse this environmental degradation. And there have been some large-scale initiatives that have been put in place to reverse this degradation. The Bond Challenge, for example, is aiming to restore and revegetate many of those degraded areas. And we've just entered the decade of restoration as declared by the United Nations. But we are really at the first stage of addressing those issues, but at least we've recognized those problems. Part of the solution is being able to harness the ecosystem services that we take for granted from our natural systems and environment. Ecosystem services are basically the life support system that the planet provides to us. It's the clean air, the clean water, the food, the materials for building, it's provision of many medicines, and it's also the kind of physical, mental, and well-being that we get by spending time in nature. It's also our cultural associations with our place on Earth. But a lot of land degradation has impacted these ecosystem services. In 50% of agricultural systems, ecosystem services have been significantly impacted. But there's a chance with particularly large-scale cropping, broadacre cropping, and livestock rearing to actually design systems that are going to be able to encourage, develop, and harness the benefits of those ecosystem services towards a sustainability solution. I don't know if you've noticed recently, but the livestock industry in particular has been getting a pretty hard rap. Some people have claimed it's responsible for large proportions of greenhouse gas emissions and overuse of water consumption. And some of these issues are true. There are a large proportion of greenhouse gas emissions coming from livestock, and water use is relatively inefficient in that system. But that's because A large number of these livestock systems are actually just rain-fed grass. So it's the rain that falls onto the pasture, and then the animals eat that pasture. They're not intensive agricultural systems, they're not irrigated systems, so they're not using more water than just falls from the sky. And many of those livestock systems are very extensive. They can be right throughout the rangelands, for example, here in Australia, which covers about 80% of the country. Rainfall in those regions is quite low. It can be below 350 millimeters, which is a pretty arid ecosystem. And farming within that sector doesn't permanently plant crops. It more uses livestock to graze around the landscape as different plants come into bud. So those are the dynamics with that particular livestock industry and some of those challenges around managing those sustainability issues. But what we're also seeing with the livestock is an awareness of the amount of meat that we're consuming and the potential problems and dietary problems with that meat consumption. And overconsumption of meat connected with the consumption of saturated fats drives non-communicable disease related to obesity, diabetes, strokes, and heart attacks. And that awareness is driving some interesting changes within food demand. And what we're seeing is an increasing shift away from a kind of omnivore diet, from balance of meat and vegetables, towards vegetarianism and more extreme cases, veganism. But those aren't the only changes. Many people are opting not to eat meat for a particular meal. These are flexitarians. The rise of the flexitarian is one of the key dynamics that we're looking at in the food sector at the moment. And when you're seeing large burger chains like Hungry Jack's respond to that by offering vegetarian burgers, the Rebel Burger, then you know that that demand from consumer is having an effect on supply chains. We've seen globally that bees have declined. We've got problems with over pesticide usage and also disease of bees that have caused a great decline of bees globally. So how can we encourage those bees back into the farmscapes and back into our landscapes? One of the reasons we'd want to encourage bees back in is because they provide an essential ecosystem service, and that's pollination services. So many of the fruits in particular that we consume require bees or pollinators to transfer pollen between plants and therefore set the fruit that we enjoy so much. We have the cereal crops, which are wind pollinated, but apples, berries, mangoes, you can name a whole group of fruits require these pollination services. So if we don't have bees within the landscapes, either we need to bring bees in, hive bees and European honeybees can do that, or we need to be thinking about the design of landscapes to encourage those bees. If we don't have the bees, then we don't have those crops and we don't have those food products that we enjoy so much. We've actually been working with a project here at the University of Adelaide to design hedgerows around key pollination-dependent crops to encourage native bees back into the landscape. We have somewhere in the region of 1,500 native bees here in Australia, and that's an awful lot of species. But we've seen a big decline in those species because of the removal of habitat. Now, many of the pollination services offered here in Australia are supplied by the European honeybee. And the European honeybee isn't native to Australia. It was introduced decades ago to help with some of that pollination systems, but also for honey production. But globally, we've seen a big pest that's coming in of European honeybees, which is the varroa mite, that's basically decimated those European honeybee populations around the world. Native bees here in Australia aren't affected by that varroa mite. So if we can establish plantings around pollination-dependent crops that improve and increase native bee populations, then we're going to be able to make those systems much more robust and resilient. And we're going to allow the kind of natural pollination services to transfer from the native vegetation into the crops. There were a couple of tricks to the design, and we've worked this out through research. And one of those tricks is you shouldn't have the native vegetation flowering at the same time as the crop that you're wanting to pollinate. If you have the native vegetation flowering at the same time, the bees will stay on that vegetation. So the trick to designing some of these plantings around the crops is to make sure you don't have plants that flower at the same time as the crops. And also, you start with plants that flower quite early in the season. That way you can build up bee numbers to a good number in time for the crop, and when it flowers and when it needs those pollination services, the bees transfer then from the vegetation surrounding the crop onto the crop, perform those pollination services, and then transfer back to the vegetation once the crop has finished flowering. It's important then that there's a continuous food source and also a habitat source for those bees in the landscape so they can overwinter and maintain populations for the next year. And the kind of work that we've been doing in this space has led to an app where farmers can actually look at their property and design particular plantings that can be planted out to support these pollination services around their particular farm. So far, we've designed the system to work with apples and pears here in the Adelaide Hills, but also with lucerne seed and other broadacre crops that occur further east and into New South Wales and Victoria. A second key area where sustainability is interacting with technology solutions is in the issues around food fraud. Food fraud is a big issue globally. Approximately there's $50 billion worth of food fraud going on every year around the world. One example of food fraud that was intercepted recently were 14,000 bottles of wine that were being exported from Australia from one of our most famous wineries here, Penfolds Wine. The label on these wines actually said Benfolds, not Penfolds, but being sold into a non-English speaking market, it's possible to fool the market because the look and the script of the label was the same as a Penfolds wine. So not technically claiming to be Penfolds, claiming to be Benfolds, but still prosecuted. And those are the types of food fraud issues that we're intercepting. If you look at the consumer demand for these types of issues, consumers, if they're spending money on premium food, they want to be sure they're getting the food that it says on that particular label. And if we look at the type of technologies that are in place that can help monitor and police those food supply chains, we have a number of markers that can be put into the foods or put into the packaging that can act as a tracer along those supply chains. You might use edible inks, or you might use some other kind of marker that can be identified quite quickly and easily within packaging. You might also use a blockchain supply chain, so you know every point that a particular product has been through in that supply chain, and you can trace that back and follow that through a digital tracing technology like blockchain. And the third type of technology is a group of tracer technologies that actually analyze some chemical or some DNA profile within the foods. And these can be used, for example, to verify that you're eating tuna and not dolphin for seafood products. Now, here at the University of Adelaide, we've been developing many of these products, but particularly to the application of timber supply chains. If we look across the world, illegal logging is a massive issue. About 30 to 40% of timber that's traded internationally is illegally logged in some form. The global timber trade is worth about $180 billion. So that puts the trade in illegal forest products up there as one of the most lucrative illegal crimes on earth. It's up there along with illegal arms trade, illegal drugs trade, and people trafficking. And also problems with illegal logging, it's not just around you buying the wrong product or potentially buying a threatened or endangered species. The problems with illegal logging also remove revenue from timber producing countries by introducing illegally logged products that often aren't part of the revenue stream within those countries. And illegal logging can also drive conflicts with forest dwelling communities, many of which just don't have the capacity to combat these types of pressures and have their livelihoods removed by these type of issues. Here at the University of Adelaide, we've been developing some DNA-based technologies which have been really critical for uncovering illegal logging activity. And you can group those into three different categories. The first category is being able to identify the species of timber in products. We've developed a whole range of tests, species verification tests, for the top 250 traded species in the world. And we've applied those tests to timber being imported here to Australia. We did this testing together with the Australian government. They did some blind shopping, as it's known. You go into wholesalers and say, have you got some timber that's come in? What species is it, and where does that come from? And that's a claim that we can check using the DNA verified technologies. If you make a misclaim on that declaration, that actually then categorizes the timber as illegal. Doesn't mean that that timber is actually illegal, but it probably does mean that the timber supplier doesn't know exactly what timber is in that supply chain. The second area that we've been looking at is a geographic assignment. So does a particular wood product come from a particular country? And again, a DNA solution has been implemented for many premium and high profile timber species. And many of these problems kind of uncover more complex socioeconomic problems. It's not just a case of banning a timber supply chain. If you ban that timber supply chain, there are many communities and many forestry workers that are some of the lowest paid within the country that will be decimated by that type of action. So being able to support legal and sustainable forest practices is really the aim here. And the third area of work that we looked at was actually to be able to use DNA fingerprinting to identify the tree that a piece of timber came from. I was rung up about a few years ago now by US Forest Service officer Ron Malamphy. The problem was that they'd intercepted some logs of big leaf maple that had been found in a local timber yard. Ron suspected that those had been sourced from a local national park because he'd seen the trees being cut about a week before. So he seized that timber, and that was the timber that we tested. We did a DNA profiling of the cut trees and also about 450 other trees around the region to build up a map of a genetic profile for the area. And what we were able to do was, from the wood that Ron had seized from the timber yard, we were able to trace that back to a recently felled tree, and that was used in a court of evidence to prosecute 4 people that were put away under the recently aligned Lacey Act to help exclude illegally logged timber products from supply chains. So this technology is being implemented, and it really is helping to tackle some of the sustainability issues that we're seeing here on this planet. But tackling these issues will also require global cooperation. There are initiatives like the Global Timber Tracking Network, the World Forest ID program, that are aiming to put together international databases of timber and using different methods like DNA, stable isotopes, wood anatomy for identification that then can be used by government and industry alike to really police some of these supply chains. Timber supply chains are often very, very complex with multiple points within the supply chain and often processing points. So it's not only a question of developing the technologies to verify the claims, but a policy framework that can provide the support and prosecutions if required, but also a deep knowledge of supply chains and when and where verification and certification claims and checks need to be placed in those supply chains to effectively police and eliminate illegally logged products. Globally, estimates are that about a third of all food is wasted. That's about 1.4 billion tons of food. And it's unforgivable that that food is wasted when we're also facing starvation issues in some parts of the world. But there are many things that we can do about food waste, from encouraging supermarkets to relax their very stringent standards of particularly fruit and vegetable quality. You might have seen the odd bunch at some supermarkets that actually focus on misshapen fruit and vegetable. That's a good thing. Those fruits or vegetables would have ended up in much lower value products, but now they're ending up on our shelves. The other area to really look at is the pyramid of food. So you move from very high value, very processed products, and then down to field-based produce. And there are different challenges at each of those places in the supply chain. Very processed foods can sometimes be recycled and reused. But when you come to the farm-based produce, some of those products can really then be diverted into other supply chains. They can be diverted into animal feed, or in some cases can actually be converted into a high-value product that is not food. Here at the University of Adelaide, we house the Cooperative Research Centre for Fight Food Waste. It was established about 3 years ago with an investment of about $65 million from the federal government and industry partners, together with in-kind contributions from over 50 partners, all working together to solve some of these food waste issues. Practical issues that can be established to reduce and eliminate food waste is really to look at supply chains and how food flows within supply chains and optimize those supply chains. Then look at industries that can be based around transformative food waste products. For example, lycopenes and other vitamins can be harvested and concentrated from food that would otherwise be wasted and make their way into nutraceutical or cosmetic products, potentially elevating the value of those products into a high value premium product. And the third component of this particular problem is really around an engagement strategy, kind of providing easy ways to avoid food waste and easy ways to tackle that right across the supply chain. So offering options to farmers, offering options to suppliers, to supermarkets, and ultimately to us in our houses and when we consume food in the restaurants. Take your food home in a doggy bag. There are a range of other kind of practical considerations that we can incorporate within there. And this type of area of science isn't just around the chemical and biochemical science of food transformation. It's also around the social sciences. It's how we receive information, it's how we make decisions, and how we change the way we approach these issues. And being able to change behavior is at least as important as the technology solutions that sit at the base of many of these solutions. And the final area that we're going to look at in the masterclass today is really the drivers of the intensification of food production. We talked a bit at the start about the extensification of food production with the livestock industry and how that can be married together with carbon sequestration and also the encouragement of pollination services. And those kind of options are available for areas of farming or types of farming that use large tracts of land. But we're also seeing globally a change towards a dichotomy between more sustainable practices in extensive farming, but more intensive farming production closer to population centres. And the interesting change around these systems is also these are often linked with our dietary changes. So we talked a bit earlier about some of the requirements and changes away from animal-based protein. The plant-based protein market is just a market which has exploded in the last 5 years, driven by this type of demand. Very sophisticated range of production and processing techniques go together to make these products almost indistinguishable from animal-based products. The Impossible Burger, for example, claims that it bleeds like a cow and uses a product called heme, which looks and tastes a bit like blood within those burgers. It's quite an extreme solution to create something that is so close to an animal-based product. But those are the kinds of drivers within the system. For a flexitarian, they might just want to go for a plant-based product instead of an animal-based product, but they don't want to change the taste profile of those. But many other plant-based products are incorporating new, more planty flavors into our diets, and over time we're adjusting to those and changing to those kind of trends. But what we're seeing is then an intensive production of a range of pulses and other plants to satisfy this plant-based protein market which is developing. And we're also seeing other areas of protein production, microbial, fungal protein production, that are also occupying this niche of alternative protein sources. And even through to animal production that's moving away from the cow in the field to lab-based protein production. Cells are harvested and then grown in vats surrounded by a nutritious solution and some growth hormones that allows the plants to replicate and divide. They're harvested and then compacted down into a group of cells like a burger or formed into a sausage or some other type of food product. It's based on animal cells. It tastes like animal because it is, but it hasn't come from the wild. Much of the cost of this production was relatively expensive. A kilo of meat cost in the region of $10,000 to $20,000. Obviously not something that you'd want to undertake or eat lightly. But because of the opportunity for extensive production, the opportunities to bring down the costs of that production are enormous. And those companies are aiming for a cost of lab-grown meat to achieve a $5 to $10 per kilo mark, which makes it very competitive in the protein marketplace. We're really getting to a situation where we're harnessing the biofoundry of plant and animal cell production. We're taking what the cells can naturally do, and we're co-opting that and changing the kind of products that we can get out from those types of systems. We call that synthetic biology. And it's not only foods that can be produced using these types of methods, but we can also produce a range of pharmaceuticals and medicinal products, and also biodegradable plastics and a range of other manufacturing materials as well. Ultimately, it's this type of technology combined with intensive production, whether that be intensive glass houses and vertical farming, urban farming. It's this type of technology that's going to allow us to move into off-world colonies. And food production from these types of synthetic biology solutions will ultimately allow us to colonize Mars. So we're coming to the end of this Study Australia Masterclass. We've been through a bit of a tour of some of the major changes that are underway in the food production systems and seen how technology and sustainability is at the basis of many of those changes. But really, to keep this advance moving, we really need to understand the technology piece within this. We need to understand where that can be applied, and we also need to help keep track of the developments within that sector. Lifelong learning, training and education is part of that piece. Training food industry to understand and adopt appropriate technologies is also part of that piece. And as John Kerry, Secretary of State, said in a recent Global Table conference, we need to make sure that the UN sustainability goals are being supported through the application of technology to achieve true sustainability. And that's the only way that we're going to be able to bring this whole system together to achieve these global sustainability targets. I'm Andrew Lowe from the University of Adelaide, and thank you for listening to my Study Australia Masterclass.